are starting a new topic this week. Okay, I think, what's going to happen this week, we're going to do one lesson. We'll be starting this new topic, which I'll present now. But very important to remember that you have a test this week. I think it's on Wednesday. I've already sent you WhatsApp messages, different times for NK and 9K and 9M. Just make sure you do that test. I think that's happening this Wednesday. By the way, what we're going to learn today is not going to be in the test, okay? So the test is going to be about acid and base and climate change. Right, so we're starting a whole new chapter. We're leaving chemistry behind, and through our discussion of renewable energy and non-renewable energy, we already kind of mentioned the word energy. So we're diving now into physics, and we're going to talk about energy, okay? So this chapter or this module, this physics module, will be mainly about energy, and then we're going to talk about something called moment. Okay. Now we discussed a lot of energy last year, but what we're going to do with energy is going to be quite different this year, in the sense that we're going to learn formulas. Okay, we're going to calculate. All right, that's a huge part of physics, okay, which we didn't really do much last year. So let's try and remind ourselves, what do we remember from energy last year? There are many types of energy, okay? Kinetic energy, thermal and or heat energy, sound energy, light energy. These are all energy in action that we can see. But there's also another kind of energy which we call stored energy or potential energy. Okay, so objects that are lifted up, they have gravitational potential energy. We're going to deal with that mainly. We have a less elastic potential energy. When I stretch an elastic band or spring, has elastic potential energy. Electric energy. Okay? Electric energy, whenever you have electricity, you've got some kind of electric energy that then can become light energy and sound. Nuclear energy, electrostatic energy, I mentioned that. Magnetic energy. Okay? These are all potential energy. We must use the word potential, chemical potential energy. Okay? If I've got some paper, I can light it up, all that heat and light will come out. That means there was some kind of potential energy inside there. It's chemical potential energy, which is in the bonds between the molecules. So what we also know about energy is that there's a conservation of energy. Energy never gets destroyed, and it's never created. It just changed from one form to the other. Okay? And that's going to be very, very important for us when we calculate energy, Okay, so we need to know that the amount of energy that we had before is always going to be the amount of energy we had after, but what was before gravitational potential energy might be kinetic energy afterward, or the other way around. Right, so to be able to solve these problems, we need to learn formulas for these types of energy, and like I said, we're really only going to talk about gravitational potential energy, okay, in this year. Yeah, we're not going to learn other kind of energy. We will learn about kinetic energy, but we're not going to learn about other kind of potential energy is what I'm trying to say. But before that, I also want to remind you another equation that we actually did learn last year, and we will still need to use it, and that's how to calculate the weight of an object if I know its mass. Okay, remember, mass and weight is not the same, okay? We learned that in grade 8. Mass is how much stuff there is in the object, okay? Where the weight is the force that pulls that object down towards the center of the earth. Okay? So they're related to each other. The more mass there is, the more weight it has, but it's not the same. How do we calculate the weight of an object? We use this equation. Fg equal mg. Fg is the weight due to gravity. F for force, a little g for gravity. Okay? That's equal to the mass, m, times g. What is g? Okay? All stuff that we did last year. G, little letter g, is the gravitational field strength. It's a number, okay? And in different planets you'll have different g's. Okay? On Earth, number g is, well, I wrote 9.8, but as far as we're concerned, we're just going to use 10. Okay? So the more accurate number is 9.8, but I'm just going to check here that I've got, for grade 9, we're going to just work with the number 10. Okay? Next year already, you're going to say, I know it's 9.8. We're just making your life a bit easy. Okay? The units of the gravitational field is Newton per kilogram. Because it basically tells you, what this G field tells you, how many newtons each kilogram weighs. So 10 newtons per kilogram means each kilogram has a weight of 10 newtons. Okay? If I've got a mass of 1 kilogram, the force that pulls it down is 10 newtons. If the mass is 2 kilogram, force will be 20 newtons. If the mass is half a kilogram, then the weight will be 5 newtons. Okay? Right. We learned that. New equation. Okay? Let's say I lifted this 1 kilogram. Let's say it's 1 kilogram. I lifted up 2 meters. How much energy? I know it has gravitational potential energy, but I want to know how much. Okay? If I want to start calculating things, I want to know how much. Then, my friends, we need to use our first equation. Okay? How to calculate gravitational potential energy. Okay? The symbol for gravitational potential energy is E. E for energy. Small o p for potential energy. Okay? So gravitational potential energy will be equal to mg. Same with mg, the mass, and the gravitational field strength, which is 10, times h. H, you can probably guess, is the height. How much did I lift it? Okay? How far up did I lift the object? So height. Okay? So please copy that down, and we're going to solve a couple of questions now. Okay. Right. Okay. We're going to just solve problems now. Okay? So 2 kilogram mass is lifted 3 meters. Calculate the gravitational potential energy it gains. Now actually, to add to that, let's first of all calculate gravitational potential energy and weight. So let's start by calculating the weights, just so we practice that. Now the weight of an object is Fg. Okay? And we calculate it, let's just use it right. Okay? So Fg is equal mg. Okay? Now what is the mass of the object? It's 2 kilograms. So 2 kilogram, okay, time gravitational field strength, I know it's 10. Okay, so times 10, that's 20 Newton. That's the weight. Now I want to calculate gravitational potential energy. Okay? I just added a question. I want to use also the equation for the weight, so I said let's calculate the weight. But now really what I want to calculate is gravitational potential energy. Gravitational potential energy, we can call it capital EP, potential energy, is equal to mgh. That's the equation we use, mgh. Okay? So the mass is 2 kilograms, g is 10, and the height, how much did we lift it up? 3 meters. Okay? 2 times 3 times 10, 60. And the units of energy, we didn't mention it, but hopefully maybe you remember from last year, is joules. Okay? We give the letter capital J. Okay? Capital J stands for joules. Okay? Some kind of French physicist that we name the units of energy on him. Okay? 60 joules is the answer. Okay? Easy. Now, we've got 500 gram mass, which is lifted 2 meters. Calculate the potential energy, and again, let's calculate also the weight. Let's start with the weight. Fg, okay, is the mass times gravitational field strength. Now, will I just multiply 500 by gravitational field strength? No, we didn't mention it, but hopefully you remember the mass has to be in kilogram. We have to work with kilograms. So get the answers in Newton and then later in joules, we have to work in kilograms. So it's going to be 0.5, right? Because 500 grams, you need to be able to work from gram to kilogram. Okay? 1,000 gram is a kilogram. Okay? So whenever we have the answer in grams, we have to divide by 1,000 to get the answer in kilogram. Okay? So it's 0.5 kilogram. I really recommend you to write down the unit here, just to make sure. Because if you're 500 gram, you might say, oh, hang on, I have to work in kilogram. 0.5 times 2, okay? Not 2, sorry, I'm calculating the gravitational force. I'm multiplying the mass by 10. Okay? 10 Newton per kilogram, and I get 5 Newton. So the weight of that 500 gram is 5 Newton. Okay? We did actually mention something like that. But I'm really after gravitational potential energy. What's the gravitational potential energy? Again, I have to work with kilogram. If I use 500 grams, it will be a mistake, okay? So 0.5 kilogram times G, which is 10, times H. I'm saying it like the English. What is the height? I lifted up 2 meters, so it's times 2. So 0.5 times 10 times 2 is going to be 10, isn't it? Yeah, 10. And the answer is in joules. So if I want to get my question, my answer in joules, I have to work with kilograms. Okay? One more. 2 more in fact. One and I'll do another one. An object lost 100 joules of potential energy. How can it lose? How can an object lose energy when it's lowered down? So it was lowered down 5 meters. Calculate the mass. Okay, so what we're going to do a lot in grade 9, what I'm expecting from a grade 9 student who wants to go on and do science in grade 10, I'm expecting you to be able to take a formula and rearrange when you need to. Okay? So far I was given the mass, gravitational field strength, and the height, and I calculate the energy. Now I'm giving you the energy and the height and the G, and you want to find that mass. Now, my recommendation, guys, okay, you don't have to take it, but you should, okay, is don't start rearranging first. First of all, substitute in the equation, okay? Look at that equation. I will give that to you in a test, by the way, okay? Put in the numbers for whatever you know, okay? What is the energy? Do you know how much energy we lost? In this case, we lost, yes, 100 joules. So write down 100 joules. Can you see far right here? Yeah. Write down 100 joules. Do you know how much mass the object has? No, that's what we want to calculate. So we'll write down N for mass. If you don't know what the answer, write down the letter. G, do you know what G is? Yes, I know. As long as I'm on planet Earth, and if I didn't tell you that I'm not on planet Earth, I assume I'm on planet Earth. Okay? So G is 10. Height, H. Do you know how much height? Yes, I was lowered 5 meters, so times 5. Okay? Now, if you do as I recommend, and you just substitute, I mean, that's dead easy. Anyone can substitute. You just put in the numbers right instead of the letters. You will get a mark. For that, you'll get a mark. Okay? Now, you rewrite that. I will write it here if you don't mind. Okay? I'll just write 100 equal, I'll do 5 times 10, equal 50 N. And that, by grade 9, I think all of you can answer. Okay? I want to find out N. How would I find out N? I'll divide by 50. Okay, to get rid of that 50. So 100 divided by 52, the answer is N. Now if I use, the answer is 2. If I work with joules and with meters, then my answer will be in kilograms. Only when I work with joules and meters, the answer will be in kilograms. Okay? So, just write that down, and let's do a couple more questions. Okay, 2 more questions, okay? Basically, we're looking at that equation, EP equal mgh, and I try every time to give you, to calculate something else. So we calculated the energy a couple of times, we've calculated the mass, and now we're going to calculate G and H, 2 different questions. So we have a 100-gram mass, and it gains 20 joules when we lift it. And the question is, how far up did we lift it? So again, we're going to just look at the equation, okay? and we look at that and ask ourselves, do we know each one of these things? What are they? So EP, that's the energy. Do you know how much energy? Yes, 20 joules. Okay, so all right, 20 joules. N is mass, 100 gram. Can I write 100 gram here? No, I have to work with kilograms. If I'm working with joules, I have to work with kilograms. So 100 gram divided by 1,000 is 0.1. G, again, I wasn't told I'm not on planet Earth, so I'm assuming I'm on planet Earth. So G is 10. And H, I don't know what H. I'm asked to calculate how far it was lifted, so I'll put H. Okay? Now I'm going to rewrite it 20. 0.1 times 10. I hope most of you know how to do it without a calculator. It's just 1. So 20 equal H. Okay? H equal 20 meters. That's the answer. Okay? 20 meters. Cool. Next one. Planet Zorg. Okay, so now I know I'm not on planet Earth. So the G is not 10. On planet Zorg, 5 kilogram mass is lifted. I meant to say 50 centimeters. So I'm just lifting it 50 centimeters. And it gains 500 joules. 50 centimeters and I lifted 500 joules. Okay? and it's just 5 kilograms. Calculate Zorg's G field. Okay, so I want to calculate the G in Newton per kilogram. So again, I'm going to look at that equation, okay, and ask myself, do I know what EP is? Yes. Anything with joules, that's the energy. So 500 joules. Do I know what M is? Yes, M is 5 kilograms. Do I know what G? No. So I'll just put the letter G. Do I know the height? Yes. 50 centimeters. What is 50 centimeters? I have to work with meters. If I want to work with Newton per kilogram and I'm working with joules, I have to work with meters. 50 centimeters, 0.5. Okay? So then, I'll rewrite this. 500 equal 5 times 0.5 is 2.5 G. Okay? And then to get rid of the 2.5, I'll divide by 2.5. G is equal 500 divided by 2.5, which I think is 200. Okay? 5 divided by 2.5 is 2, so it's 200. So G is 200 newtons per kilogram. So in planet Zorg, G is much bigger than planet Earth. It's 20 times bigger. It means that every kilogram in planet Zorg has a weight of 20 newton. 20 newton? 200 newton. 200 newton. Okay, guys. Your homework or your classwork, whatever you want to call it, is to do question 1 and 2. All the questions 1 and 2 on this sheet that I will upload for you onto the system. See you guys next week.